I'm Cassie, and I'm going to walk you through question 27 of the AAMC's official physics question pack. So this question is related to passage 4, and if you go back and take a look at my video I made for question 25, it actually sort of answers that question in the midst of explaining a bunch of other concepts, so I highly recommend you check that out first. But what this question is asking is essentially, once some photons have hit the cathode with enough energy to overcome its work function and eject some electrons from the metal, what happens to those electrons? So in other words, on my diagram here, right, I had light that hit my cathode, which is made of metal, overcame its work function, had more energy than its work function, and then the result was that we ejected some electrons. Now, how are those electrons going to travel from my cathode to the anode? Are they going to experience an acceleration? Is it going to be constant? Are they going to stay still? Are they not going to move? Like, what's going to happen to them? The question is asking. Well, let's go back and think about what's going on with our electric field here. We're told in the passage that between our cathode and our anode, there's an electric field of 50 volts. The definition of an electric field, at least one of the definitions, is the force felt by a test charge placed in it. In other words, you can think of our electron here like a test charge that's been placed in our electric field of 50 volts. So we know based off of that definition that our electron is experiencing a force. Remember our classic equation you need to know for force for the MCAT is force equals mass times acceleration. So if our electron is experiencing a force and the mass of our electron is not going to change as it moves from cathode to anode, this is going to stay constant. It's not going to change. Well, then we must be experiencing some acceleration, because if our mass is not changing, but we're again experiencing a force, then we must be experiencing some acceleration. And if it's experiencing some acceleration, then we know we can eliminate all the other answer choices except for C. Not moving with constant speed if it's experiencing acceleration. It's also not staying stationary. And the other answer choice about exiting through a side, that's just one of those classic MCAT irrelevant answer choices that you can eliminate right away. So our electron here, it's going to accelerate towards our anode. And we also know that that means that its kinetic energy is increasing as it moves towards the anode. And why is that? Well, just to review really quick, remember our equation for kinetic energy you should know for the MCAT. Kinetic energy is equal to 1/2 mass times velocity squared. Again, the mass of our electron is not changing, but if our acceleration is constant, right? So if we have acceleration versus time, this is a graph, and our acceleration is constant, then we know that our velocity must be increasing. So if our velocity is increasing, therefore our kinetic energy is increasing as well. And we know that, of course, because velocity equals acceleration times time. So if we have acceleration here, then we're also going to have an increase in velocity here. And just a side note, make sure you understand, like, being able to quickly, like, if you're given an acceleration, you're able to picture what the graph of velocity versus time would look like, or even position versus time. Since acceleration, for example, is the rate of change of velocity over time, if I have a linear increase in velocity, my rate of change is constant. So then my acceleration is just a constant line here. And I've seen other MCAT questions that just test your ability to, given a graph of velocity versus time, know what the graph of acceleration versus time is. Or for position versus time as well, right? So if we had position versus time graph and a velocity versus time graph, and let's say the position versus time graph is exponentially decreasing, then the rate of change, slope of that position versus time graph is going to be, again, a linear decrease. And then if I were to take it one step further and I wanted to know, given the graph of position versus time, what would the graph of acceleration versus time? Well, first I'd go and I'd draw the graph velocity versus time as a linear decrease, and then I'd know the graph of acceleration versus time was just a straight line, a constant amount. So make sure you understand velocity is just the rate of change of position over time, and acceleration is just the rate of change of velocity over time. So if you're given the graph of any of those three quantities, you can get an idea of what the graph of the other two would look like. So I hope this helps. Give it a like if it did, and subscribe to follow my channel for more content like this.